So, good morning. We will talk about geographical information system in this presentation. I'm Manuel Salvatori. I work for NetNames, a company based, of course, here in London. I'm a tech lead. I'm from Italy, and usually I attend to the Italian meetup. We are going to talk about GIS really quickly, of course. I will describe some data related to geographical information system. I will try to clarify how we can actually publish data, geographic data, and I will list some technology I suggest you to look at if you want to get started with those kind of systems. So first of all, GIS stands for Geographical Information Systems. The geographical aspect. We live in a world that can be represented by points, line, polygon, and more than that. For example, we are in London. London as an area, so we can identify the London area as a polygon. We are in a building. This is a point in the world, maybe a point in the map. So what does it mean? It means that in a system, we can represent geographical aspect now, and we will look at this, the importance of the geographical aspect to get information we need. The information, until around 15 years ago, data for us was string numbers, dates, binary data. But then people started needing something to correlate the position at the beginning, mainly. So they started creating those latitude and longitude. Oracle did a great job creating a set of data type afterwards, geography, geometry, and a lot of functions that allow you to query in geometries, as well as you query for dates or numbers or string. You can do the same with geographic data. We'll discuss about that a bit later. But this is an example of how we actually get standard data, alphanumeric data, with geographic data, and we have to define a correlation between the two. So in this case, this is a table that contains some data. Maybe you won't be able to see from the button, but there is a column on the right-hand side that is stored in binary, and there is a geometry information. So in this case, it's not denormalized. You have the same data in the same table, but of course, you can join multiple tables in the same database, and you have to identify which is the relation between the alphanumeric data and the geographic data. So the system itself has to go through those data and provide the right information to the user. Now everybody knows about those things. This is Zoopla that is used to search properties. This is Move It that is really useful to actually find the proper journey to reach some place. This is a clear example of the capability the user has to search using alphanumeric information. So for example, if you're looking for a house, you can specify the type. You can say, oh, I want at least 2 bedroom or 3. And this is a simple filter where bedroom number greater than 3. But in this side, we can also draw a shape, a polygon, and the system below will filter, will perform a geographic query, and according with your geometry, your polygon will query all the property that will match the geographic filter and the alphanumeric filter. So here the relation is clear between houses where are located and your shape, the shape you drew to filter. So the system has to automate this and transform the raw data into useful information. What kind of type we can publish in a geographical information system? Of course, images, rasters. We all know Google Maps, sat view, for example. Google scaled this, exposing 1 tile per server or something like that. Is really fast. But the problem is that anyway, the payload of images, as we seen earlier, is quite important. So along the time, even if there are techniques to optimize, like create pyramids, the community started to create new standards to deliver data information. And this is, for example, a GML format that's really similar to the XML markup. In this way, we can reduce a lot the payload. And in the client side, of course, we have to render those information. So we can reduce the amount of data we use, but we have to load a bit the client to render properly the maps. There are some examples online, and the outcome of the rendering is usually something like this. This is very simple without proper styling. This is rendered in the client side, but using some style. So if we want to create a new geographic information system, even if it is simple, we need some data, as I said, some geographic data, and we can store those geographic data in a shapefile, raster, GML, a geodatabase, and we will see later some technology we can use. We need to identify the formal relation. We do need to do our job, coding a bit, overnight maybe, and publish the system. And we will talk about that soon. Hopefully, most of you recognize this SQL syntax. This looks like a simple query, right? So we have a select. We specify where we want to select some data. And in this part, we apply a condition. This is really similar to what Zoopla does. In this case, the example is, imagine we have a database, a table with the houses, the information related to the houses. And we have another table where we store all the areas that are affected by landslide risk. So it is raining a lot in this month, and I work for the government, and I want to notify the landlords in that area to say, look, there is a risk that the river is flooding. So what do? I select the name from the owners. I select the email and the house address, maybe. From home, that is table that contains the home information. We join that with the owners using the simple ID, blah, blah, blah. But homes contains also a geographic column called home geometry that contains actually the point, the exact location in the map. So what I can say using this function, this is a function from PostGIS, we will look at that later. So it says intersect. It's pretty clear, right? So you want to intersect the home geometry, right, with the result of this inner query that is a union, clear. So we create a union of area geometry from the landslide risk table. So imagine this table contains all the geometry, all the areas of the area of a territory, maybe, and each area with a different risk level, maybe has an alphanumeric value next to it. So we say, where risk is higher than 3, that may be dangerous, I don't know. We create a union, so the outcome will be one unique geometry composed by different one, maybe. And if the house intersect that geometry, we will send a notification. We will collect the data back. There are other functions really interesting. For example, buffer. I want to see, oh, look, I add to the home geometry 200 meters. So I know that I can send a notification also to people that are just net risk area. So what do we need to publish? As we've seen in the screenshot earlier, we need a web application, a desktop application, a mobile application maybe. And where do we get those data? Is almost like all the other systems. We need a service layer, a backend layer. We can expose web services using RESTful, maybe exchanging JSON. And we need the data layer that publish those information where we can query. And we have to store the geographical information. So about the publishing service, that is probably what you are interested more as a developer. There are a lot of type of services. The main two standard are the web feature service and the web map servers. The first one produced GeoJSON, JSON, or GML, as we've seen earlier, that is text, so really lightweight. But with this information, we need to render the geometry if we need. The web map service, instead, acts almost like Google. So you specify an area, and it will send you back the right images you want to see, depending on the zoom level, for example. And this is an example of the syntax. It's pretty straightforward. In the query string, we specify the type of service, the version. We specify the type of request. I want to get some feature, in this case. We specify the layer name. You can use also namespace, but this doesn't really matter now. So for example, I can say, oh, I want the land risk layer. I specify another important aspect, that is the reference system. So geographic data can be stored in different ways. So when you store those data, as you do when in a database, you specify the length of a text or the precision of a number. For geographic data, you have to specify which is the reference system. It's really important because if you specify that and other systems are using your data, they know exactly how to manipulate those data using algorithms, converting those information, and allowing them to cross-query those data. So this is an important aspect. And if you start using geographical information system, maybe you want to look at the standard web, that is the actually the reference system created by Google some years ago, called with a number 913. That stays for Google exactly. But now it is become a standard. It is called 3857, and that's the one that I suggest you to use, because allow you to be independent from the specific country or location detail. So the last parameter is the bounding box, is the area you are interested, the area you are querying. Storage technology. The shapefile is a file widely used. It was created by Esri, the very first commercial company. Stores different type of information, geographic information, alphanumeric information, indexes, and so on. Raster, we mentioned earlier. So we have JPEG, GeoTIFF, and so on. Also GeoPNG, that is not good, as we learned earlier. The GML is another format. You can store information directly in files, but it's not really useful. It's more useful for exchange. And the most powerful one is, of course, a geodatabase. Like we've seen, you have clear query, you have function, and you can cross filter your data. Some front-end technology. OpenLayers is the most popular JavaScript framework to render maps, view maps, maybe draw on the maps. It's really easy to use. In the website, you can find a lot of examples, and it's really fast to learn. Leaflet is actually getting popular and is now competing with OpenLayer, but I still prefer OpenLayer. GISCloud is an interesting commercial website that allows you to publish data directly. So you have everything you need. The server side, you have the storage, you can upload your data. It's really fast, and they use dynamic rendering in the client side. So the exchange between the server and the client is really lightweight. MapWinGIS is provide different things, but I've been using the OCX for a .NET desktop application, provide some API to render a map in a standard C# application. Yeah, some code. So this is an example of OpenLayer. Maybe you cannot read, but maybe confusing, but if you see, it's quite easy to understand, because we instantiate a new class that is a server vector, and we specify some information like the format of the data we want to get, that is GeoJSON in this case. We specify the URL that is similar to the one we saw earlier, is using a WFS service, and we specify the APSG, that is the reference system, the new Google standard one. We specify the bounding box, so the area we are looking at. And after that, we start creating the tile, and we specify the projection of our own website. That's why it's important, the APSG, because the source may be in a different reference system. So this is how you actually start getting the data. And then you have to compose the map and display in a website. But as I said, in the OpenLayer website, the examples are really clear. Storage. So PostGIS is the open source, most popular probably, geodatabase. They are competing really with Oracle, that is the older DBMS that implemented geographical function and geotype. MySQL is a bit slow, has SQL Server actually, and they are not really used. I noticed that, for example, here the market is pushing for a Esri solution, and they use a lot SQL Server and Oracle. In the open source world, for example, in Italy is really strong, the open source world for a GIS system. PostGIS is the first choice. Of course, if you provide data, and maybe you need to manipulate those data, so those tools may help you. Those are commercial, except this one that is open source. Esri, that is the most popular. Intergraph, GeoMedia, is quite competing. There is a UK company, CatCorp, I used for a while, but yeah, probably those two are the most powerful. Even though my suggestion for you is QuantumGIS, that is open source, is really powerful, and I quite like it. As a very proactive community that they keep releasing changes. MapWindow is provided by MapWinGIS, and that is the same provider of the OCX we've seen earlier. And there are a lot of many other WebGIS where you can actually edit your data. Publishing, really important. So to publish, if you don't want to use a third-party application, you can install a GeoServer or a map server that are both open source. But GeoServer is really, really easy to learn and to get started with. They have a great community, and I suggest you to try that if you want to publish data yourself. There are many other, of course, from all the commercial parts. And this is the suggested stack from my point and my experience, of course. If you want to get started, you don't want to pay licenses right at the beginning. So at least you can start with those frameworks. OpenLayers for the UI. GeoServer to publish the data. As a storage, you can use PostGIS. And QuantumGIS, as I said, you can use it to manipulate the data in the backend, offline, and then publish it. Openstreetmap is a good alternative to Google Maps because it is free. It's completely free, because even though Google Maps is free, if you start having quite a lot of visitors and you reach the number of limited free access, then you have to pay. But of course, if you get started, you can use Google Maps because you won't reach that high level of accesses. I point this, that is the UK government website for the open data, and gives you a lot of useful data that you can publish and you can use to provide new application. And that's all, and enjoy your lunch. Hopefully you liked my presentation.